So, we've all heard the hype. AI is totally changing the game for programming. But, anyone who's actually rolled up their sleeves and tried it knows the real story. It's an unbelievably powerful tool, for sure, but you can't just toss a task at it and expect magic to happen. To really make it work, you've got to have a new mindset, a whole new workflow, because it's not about what the AI can do, it's about how you manage what it does. And yeah, this quote right here, it just nails the feeling, doesn't it? If you've ever used an AI to write code, you know exactly what this means. One minute, it gives you this perfect, beautiful solution. The next, it's a complete train wreck. That randomness is so frustrating, and it really feels like you're just rolling the dice every single time you hit generate. But what if you could actually tip the odds in your favor? What if there were a set of rules you could follow to turn that sheer luck into reliable, consistent results? Well, guess what? There are. And that's exactly what we're going to break down right now. The practical principles you need to manage your AI and, yeah, make your own luck. Okay, so first things first, you have to wrap your head around the central paradox of coding with AI. And honestly, the best way to think about it is this. Imagine you just hired a brilliant intern. They're super fast, they know a ton of languages, and they can crank out code at a mind-blowing pace. But, and this is a huge but, they have zero real-world context, they make all kinds of careless mistakes, and you have to watch them like a hawk. That is your AI, incredibly talented, but totally reckless. This brings us to a really key concept, AI programming competence. The most important thing to get here is that an AI's ability to produce good code isn't a fixed thing. It changes all the time depending on what you're asking it to do. And what that means for you is that you can't blindly trust its output. Not ever. You have to be the senior developer in the room, carefully reviewing every single piece of its work. So, how do you deal with all that variability? Well, it starts with our very first principle. You have to be smart about the tasks you give it. This isn't just about generating any code. It's about generating the right code for the right job. And that means you've got to choose your battlefield wisely, starting with the language and the complexity of the task. For instance, the AI's competence can vary wildly depending on the programming language. If you ask it to write something in a low-level language like assembly, it's going to have a bad time. There just isn't enough training data out there for it. It gets a little better with something like C, but where it really shines is with super popular languages like Python or anything web-related. And why is that? It's simple. The internet is absolutely flooded with examples for it to learn from. And it's not just about the language, it's also about the complexity. AIs are fantastic at the boilerplate stuff, simple functions, basic UI elements, all the things that have been done a million times before. But the second you ask it to handle complex, multi-layered logic with your own unique business rules, that's when things get shaky. It's just trying to stitch together patterns it's seen before, and it can get lost really, really easily. All right, this leads us to what is, without a doubt, the most critical, most actionable piece of advice in this entire explainer. Seriously, if you remember only one thing, make it this principle. This is the golden workflow that is going to save you from countless bugs and massive headaches. I call it the one change rule. The rule itself is super simple. First, you ask the AI for one single isolated change, nothing more. Second, and this part is totally non-negotiable, you review every single line it wrote. I mean, every line. Once you're positive it's correct, you save that new version, and only then do you repeat the process for the next small change. I know, it might feel a little slow, but trust me, it is infinitely faster than trying to debug a giant mess later. And here is exactly why you have to review everything. AI models can and absolutely will make changes you didn't ask for. You might just ask it to change one little variable name, and it decides to helpfully refactor a completely unrelated function, and in the process, it breaks it. It can do this even if you specifically tell it, do not touch anything else. Remember that reckless intern? This is them trying to be proactive and just causing total chaos. Okay, so once you have that one change rule down, it's going to help you with our third principle, which is all about avoiding the most common and most dangerous traps that developers fall into when they're using an AI assistant. The first big trap is letting the AI refactor your code just for the sake of making it cleaner. See, the AI looks at your code and sees what it thinks is just repetitive junk, and it wants to simplify it all into one elegant little function. What it has no way of knowing is that you, the human programmer, might have repeated that code on purpose to handle very specific, nuanced edge cases. The AI's cleanup can completely wipe out that critical logic. The second major pitfall, cross-platform compatibility. You can ask an AI for a script that works on Linux, macOS, and Windows, and it'll confidently tell you, sure, here you go. But you absolutely cannot trust it. I'm serious. It probably doesn't know that the version of a tool like Bash on macOS is way older and different from the one on Linux. The only way to be sure your code works everywhere is to test it everywhere, manually. Now look, after all these warnings and rules, you might be sitting there thinking, wow, this sounds like a lot of work. And you're right, it is. But it is so important to put all these challenges into perspective because this technology is not standing still. Not for a single second. You really have to appreciate the speed of this change. The quality of AI-generated code right now is already orders of magnitude better than it was just a few months ago. This isn't a slow crawl, it's happening at a breakneck pace. So while all the principles we just talked about are absolutely essential for today, we have to expect even more capable, more powerful models to show up very, very soon. And that kind of leaves us with one final thought. These core ideas, choosing the right task, sticking to a strict workflow, and always remembering the AI's lack of real-world context, they're not just about managing today's reckless intern. They're about building the foundational skills you're going to need to partner with the even more powerful AI tools of tomorrow. So the real question isn't just about today. It's how are you going to use these rules to get ready for what's coming next?